All right, today we're jumping into 15 projects that are literally pushing us past our natural limits, taking us into, well, superhuman territory. So let's dive right in. It's a question that has pretty much defined our species. For centuries, we looked to biology and physics for the answers, but now, a whole new set of tools, all driven by AI, is completely changing the game. It's pushing the boundaries of what our minds and even our bodies can actually do.
And that's really the core idea for our countdown today. This isn't about replacing human intelligence, not at all. It's about augmenting it. It's about giving us the endurance to work tirelessly and the ability to see patterns that were always there, just hidden in plain sight.
So, our journey is going to start with perception. We're talking about tools that let us see and understand the world on a scale that was, honestly, just impossible until right now. Okay, kicking off our list at number 15, this one is a genuine game changer in modern biology. I'm talking about AlphaFold. So to put this in perspective, before AlphaFold, figuring out the structure of one single protein could take a PhD student years of work. Now, DeepMind has predicted the structure for pretty much every known protein on the planet. I mean, we're talking over 200 million of them. It's already been cited in tens of thousands of research papers, and it's speeding up everything from drug discovery to fighting diseases. All right, at number 14, this is where AI stops thinking in separate boxes. We're talking about multimodal models, like Google's Gemini. They can process text, images, audio, video, all at the same time. And what's so important about that? Well, it's way closer to how we naturally combine signals to understand the world. So think less chatbot and more like a relentless pattern spotter that literally never sleeps. Okay, coming in at number 13, this amazing pattern spotting ability actually gets a job. It becomes what we call a cognitive co-pilot for some really high-stakes professional work. And what's really fascinating here is the distinction. We've got studies from places like MIT and Stanford showing that experts, we're talking lawyers, doctors, when they use an AI assistant, they finish their work 20 to 40% faster and with fewer mistakes. And look, this isn't about beginners just outsourcing their thinking. This is about experts using AI to clear out the mental clutter, manage their memory load, and ultimately make better decisions because they have more context.
And by the way, this whole co-pilot idea isn't just for medicine or law. It's popping up in creative fields too. A great example is a tool like Overseer OS. It uses that same principle, analyzing successful YouTube channels to find the patterns in their structure. That saves creators from months of just guessing and checking. See? It's the same core idea. Let the AI handle the heavy-duty analysis so the human can focus on what they do best, judgment and creativity.
Okay, for number 12, the superhuman ability we're talking about isn't really intelligence, it's just pure, raw endurance. These autonomous research agents can run thousands of simulations and experiments 24/7 in fields like chemistry. A human lab team? No way they can keep up with that. So the real breakthrough here isn't a superior brain. It's the relentless persistence that just completely changes what's possible in a set amount of time. All right, so we've augmented our perception. Now let's move on to augmenting our actual physical selves, connecting AI directly to our own biology. So this next one is probably already on millions of wrists right now. I'm talking about wearables from Apple, Google. They're using machine learning to constantly analyze your health data in the background. Now here's the crucial point. These things don't diagnose you. What they do is flag anomalies early on, sometimes days or even weeks before you would ever notice symptoms yourself. And in healthcare, timing can change everything. Okay, so 60 words per minute. What is that? Well, that's the speed at which our number 10 technology, called neural decoding, can translate brain signals directly into text for patients with paralysis. And what's absolutely incredible is that this is now happening with non-invasive systems. We're getting close to the speed of a natural conversation, all without needing surgery. Just amazing. And this is a perfect example of the huge shift happening in robotics. Old prosthetics, they just followed a rigid set of pre-programmed rules. But the new generation, our number 9, uses AI to actually learn from a user's unique muscle signals, and it does it in real time. The result, movement is smoother, it's less tiring, and it just feels way more intuitive. The machine is finally adapting to the person, not the other way around. Let's be honest, robots have always been kind of clumsy, right? They've struggled with dexterity because the real world is messy and unpredictable. But at number 8, reinforcement learning is totally changing that. By letting a robot try a task thousands, even millions of times, it learns how to do it through pure trial and error.
So again, the big breakthrough isn't one single brilliant move. It's all about persistence. Our number 7 is just a story of pure, mind-blowing scale. So researchers at MIT needed to find new antibiotics. Normally, that's years of painstaking lab work. Instead, they used an AI model to screen over 100 million chemical compounds in just a few days. It found a really promising candidate called halicin, which turned out to be effective against those nasty, drug-resistant bacteria. This isn't about the AI being creative. It's about its ability to search a space so huge that a human team never, ever could.
All right, for our next section, we're going to zoom way out, because these next technologies aren't just about augmenting one person at a time. They're about redesigning the fundamental building blocks of our entire world, everything from computation to biology itself.
So you've probably heard about quantum computers. They're ridiculously powerful, but they're also super, super fragile. Like the tiniest little error can completely ruin a calculation. That's where number 6 comes in. AI is basically playing the role of a stability system, detecting and correcting those errors in real time. It's not making the quantum computer smarter, it's making it usable. It's turning a cool theory into something we can actually work with. Coming in at number 5, AI is basically adding a crucial safety layer to one of the most powerful tools in all of biology. You know CRISPR, right? It lets us edit genes, but there's always a risk of making accidental, unintended cuts. Well, machine learning models can now predict where those off-target mistakes are most likely to happen. This lets scientists design edits that are way safer and a whole lot more precise.
Okay, let's be super clear about this one. AI has not solved aging. But, and this is a big but, at number 4, it has dramatically changed the speed of longevity research. By digging through these massive data sets on how our cells age, machine learning can spot patterns that a human researcher would just completely miss. This means hypotheses that used to take years to even investigate can now be modeled and tested incredibly quickly. Okay, this next one at number 3 is something that I think doesn't get nearly enough attention. DeepMind's system, called Genome, basically flipped materials science on its head. It took it from a slow, painful process of trial and error and turned it into a giant search problem. The result? It's predicted hundreds of thousands of new, stable materials. A lot of these have already been created in labs, and they have huge implications for things we desperately need, like better batteries and semiconductors. Coming in hot at number 2 is what I like to call the partnership model. In really critical fields, think radiology or climate science, the AI is not making the final decision. No way. Its job is to crunch all the data, highlight the weird patterns, and flag anomalies for a human expert to look at. The AI sharpens the perception, but the human keeps the final judgment. It's really that co-pilot concept we talked about, just taken to its most refined level. And that brings us to number 1. If everything we've talked about so far removes our limits in an indirect way, well, this final technology goes right to the source. It touches the limit itself. This is it. This is the most direct form of human augmentation that exists today. Brain-machine interfaces, or BMIs. They use AI to create this direct link between brain signals and an external machine. We're already seeing early trials where patients with paralysis can control a computer cursor or even type, just by thinking. It really is the ultimate fusion of human intent and pure computational power.
So, what's the final verdict on all of this? Well, from our very biology to our own thoughts, AI is proving itself to be an incredible tool for augmentation, not replacement. It gives us that tireless endurance and that inhuman ability to see patterns, but it leaves the most important part, the judgment, to us. And as these tools get woven deeper and deeper into our lives, they leave us with one really fascinating question to ponder.